Hello, everyone. Welcome to what is the last session of the LLM track of PyData Global. Thank you so much for joining us. Feel free to use the chat to connect with fellow attendees and share your thoughts during the session. If you have any questions, please post them in the Q&A tab and we'll address them at the right point of the session. But it is now my pleasure to introduce Sonam and Akshay. They will be presenting their talk, Vector Streaming, the Memory-Efficient Indexing for Vector Databases. And please, let's give them a warm welcome.
Thank you. So, shall I start? Let me share my screen. Okay, 1 second. Hi everyone. So today I will be presenting vector streaming, our memory efficient indexing method from Embed Anything. I'm Sonam Pankaj. I'm the co-creator of Embed Anything, and I also work at Articulate as generative AI evangelist. I'm joined by Akshay Ballal, who is also the co-creator of Embed Anything and is from joining us from TUI in the Wine. Okay, so uh, along the way we will be comparing our framework with other frameworks as well. So let's begin with one question. What does RAG quality depends on? I'm hoping everyone knows here about a bit about retrieval augmented generation. So the quality depends on retrieval, which again depends on the embeddings. Now, what are embeddings? Embeddings are a numerical representation of your any kind of unstructured data source, documents, PDFs, your images, and they cluster together based on similarity. Here I have represented the MNIST digit data set, which has clustered together similar looking digits. It can be used in RAG, that is for context injection. It is widely used in search, recommendation system, classification, like all classical machine learning problems. Um, so, what is Embed Anything and where it comes to play? So, Embed Anything is Rust Power Framework, which enables your any kind of unstructured data source, be it images, be it PDFs, be it audio, to your vector database. So we have got 100,000 downloads in this past 5 months, and we have gotten like 300 plus stars. But one thing that kind of is very different from other platforms, it's built from the ground up in Rust. So there are three parts of Embed Anything. There are three engines that are working coherently together. The first is the ingestion, inference, and indexing. What does ingestion do? So ingestion is responsible for all your pre-processing of data. We also do OCR, text cleaning, and especially metadata extraction. We also do semantic chunking for your RAG applications. A different kind of semantic chunking tools is also present. Then inference. Then inference is done both on Candle and on ONX. Why Candle? Because it's built on Rust and it has been built specifically for the transformer based models. And why ONX? It allows quantized models. Recently, we also released ColPali version of our ColPali ONX on our Hugging Face model. So we are also releasing models apart from this whole infrastructure. And we support dense models like BERT, GINA, we support sparse, ColPali, CLIP, Whisper models. And the major part of Embed Anything, that is vector streaming, that we will discuss in details today. So all these three parts have been written in Rust, and one of the major goals of 2025 will be also to include fine tuning in the framework. So we will discuss vector streaming in details, that is how it works and like what it is. So the problems that used to exist majorly with frameworks, heavy frameworks, was they used to have very high memory footprint and a lot of dependencies. So LangChain and Llama Index, you must be knowing, they have a lot of dependency. It has very high memory footprint. Most of them are cloud based. Doesn't provide metadata extraction. Some of the frameworks, and then no pre-processing. So the problem with heavy framework is it's very difficult to maintain, and it comes with a high technical debt. So building a POC is okay, but putting it to production is a very different thing. And embed anything by design, because it's built in Rust, it avoids tech debt. Uh, so the highlights as highly performant, that is, it's a very high speed, plus the embeddings are very accurate. It's minimalistic. So what happens is Candle doesn't use torch, so we have removed even torch from the dependency. We were able to remove torch from the dependency and make it very lightweight. Multi-source, we ingest multi-source from PDFs to Markdown to other sources as well. Multimodal, we ingest audio files, images, etc., and lightning fast. Okay, so here is a comparison of performance with embed anything, fast embed, and sentence transformer. This only include the inference part, and it doesn't include the ingestion and the indexing part. So if we start including those, the gradient increases. That is, embed anything becomes much faster. This only measures the embedding model inference speed and is based on ONX model runtime, and it has been repeated hundreds of times to kind of simulate a high number of documents. And these are available in our benches in our GitHub repo. So coding in Rust for what it feels like coding in Rust for half an hour. So don't worry about it, because I get a lot of question about, do I need to know Rust to use them anything? So the answer is no. You don't need to worry about Rust at all. Most of things have been given in a way of like just adding some parameter like buffer size, config size, that Akshay will go in details. So now I invite Akshay to take over the stage. Thank you.
Yeah, Sonam. Thanks for the presentation. I think you have to stop sharing your screen so I can share.
Yes, done. You can share
Yeah.
your screen.
Yeah. Can you just confirm if my screen is visible?
Yes.
Yeah, great. Yeah, thanks Sonam for a great introduction to Embed Anything. So we'll slowly get into like what the topic is of vector streaming as well, and what different we do from other libraries. But before that, we'll get into some technicalities on how the library is built and what allows us to do what we do. So first thing is, yeah, we initially envisioned this library as a Rust library, but we found that the adoption was a little bit slow because Rust is still not nascent, but it is still something that is growing, and people wanted to start using it right away with other existing libraries which do with the databases. So it interacts well with those. So we- Python was the obvious choice because most of the whole ecosystem is using Python. So what we have done is we have taken Rust and exposed it to Python using Maturin, which is a PyO3 provider. So it converts a lot of Rust functions into Rust bindings, and we can execute those from Python. So this helped us to like grow much faster and let more people start using embed anything much faster. So but why have we used Rust? Like we could have done the whole thing in Python. So one is we wanted it to be very memory safe, because when you're dealing with embeddings and this large models, things can quickly grow a lot if you don't manage your memory well. You will basically have memory leakage, and a lot of memory will be used, especially if you're using cloud containers. You'll be out of memory, and memory is not cheap. You will have to have containers which need more memory, but here we have tuned that for you. And also we have a strong in Rust we have a strong way to have concurrency and multi-threading, also multiprocessing, which is used in vector streaming, as we'll see a bit down the line. But the problem is not all people know to use Rust, especially in the ML and AI field whom we want to cater to. They do not use Rust, so it's more and very difficult to learn. So that is one of the reasons we wanted to also expose this to Python. And Rust has doesn't have a very big ecosystem. Not all the databases support Rust, so that is something we wanted to also. That's the reason we wanted to move to Python as well. Yeah, everyone knows Python. Python is great. It has a great ecosystem. It integrates well with other languages. Like we are able to use Rust with Python. So in that way, it's a great platform to like serve serve your infrastructure. So but the problems are the GIL lock, which most of you would have heard about by now, because 3.13 is opt out removing it. So you have to like you can opt out of using GIL. So that is something that will be in the future versions of Python, but it's not stable. So it's going to take a few years at least to do that. But yeah, what this would allow eventually for Python to do is a lot like Rust in terms of multiprocessing and multi-threading. But also Python is not type safe. We wanted to keep the whole system type safe so that it's much easier to develop down the line and we don't build up technical debt. So something Sonam also mentioned is about the Candle framework. So that is something that unlocks a lot of performance in terms of vector streaming as well. So what Candle framework helps us do is do the inference. Obviously, it's like a PyTorch replacement in Rust. So it is being built from by the team at Hugging Face. So it's almost like a PyTorch like library for, but mainly focused on inference. It can do training as well, but the training part is not very well built yet. So right now it's more focused on inference, and this is the backbone of our model, our framework as well. And yeah, as there's no torch dependency, this can be easily put into a binary and served locally, or served deployed anywhere in a container as well. And so, yeah, so it's very easy to deploy. And also one of the biggest selling points of using Candle, and so for embed anything, because it is built on Candle, is you can deploy it into a browser. So it can run in a browser using something like using a WebAssembly. So you can make it a binary and the browser can use it. So can basically serve your product in a browser, and the compute is used by the host computer, so you don't have to even have a server then. So if you have any product which uses edge based inference, so this is something that can be used and easily integrated into that solution. And we do a lot of document pre-processing on our end as well. So basically, if we give it a PDF, we can break it down into smaller chunks. And chunking is not very easy. It might seem very easy, but the quality of RAG depends a lot on how things are chunked. And one of the smart techniques that we are using with embed anything is we provide semantic chunking, which basically makes the chunk such that the most of one of the topics is within a chunk, and there's not a lot of topic change happening within a chunk. So this makes the chunk more cohesive and helps in giving better RAG as well. So this is something we can do because we are using a lot of models. So you can have a separate a small model for semantic chunking and a larger model for your final embedding as well. And we do text cleaning, so we can define what all we want to clean within the chunk as well, and like extra symbols and those kind of things to make the chunk even more cleaner. Also we get the metadata, like which page does the chunk belong to, which file has it come from, a lot of metadata about the file itself, if you want to have like when was it created, what was the complete path of the file. So those things can be extracted and put in the chunk, and eventually that is moved to the database as well. And also we support OCR. So if let's say your document is not a complete a text document, it is more of a scanned PDF. So right now we are supporting test-tracked OCR, but eventually we want to have more OCR models, so like GOT OCR and much more newer models like layout LM as well to be used for this. So now coming to why we need to have vector streaming. So uh, basically we want to reduce the memory requirements that embedding library can have. So for example, something like llama index or something, they do not use vector streaming, so they have a higher memory footprint. And also, if you don't use vector streaming, basically you are embedding all your chunks at the same time, and you might use a batch size, but all of those chunks and the embedding stay in your memory for until they are moved to the database. So you get your first output only once that whole thing is completed. And so basically we, with vector streaming, we are trying to send all those chunks and the embeddings directly to the vector database, so your memory is free all the time, so you're using the database as a memory for the embeddings. So let's quickly see how this works. So basically you have your PDF. We go through the PDF, and there's a separate thread for each pre-processing each page essentially. So each page is treated separately, and they're all pre-processed separately. And as soon as a certain page is completely pre-processed, so pre-processing includes the chunking and the OCR model and those things, it is moved to a chunk queue. From this queue, then it is then fed into the embedding model, which runs on a separate process. So this is happening completely asynchronously on a separate process. So you're not waiting for the pre-processing to be done, or you're not waiting for the embedding model to run at the same so they're running at the same time essentially on a each on a separate process. And when an embedding model gives its output, that is moved to the vector database. So this might seem synchronous, but what is actually happening is more explained in this diagram, that there are two separate processes running. One is mainly for pre-processing, and one process for embedding. So this process is not a separate service that is spun off. So like, some you might compare it to something like Olama or something like that, which has a complete whole backend and a process that is running separately. This kind of emulates that, but within the application. So this kind of in memory process. So we can have a look at what is happening in the main process as well. So the chunking part is happening over here, and as soon as the embeddings reach the main process, after them it is moved into the vector database. So this helps us keep the memory footprint very low, because we are not storing any of the embeddings in the system memory and moving it to the data as soon as it's done. And this is all happening asynchronously. But yeah, so basic implementation of this is in Python. Like, you would have to use this in Python if you're using it now. So but you don't have to worry about all these processes, spinning off a process yourself. So essentially, when you give this piece of code, this is all done in the background. So you just have to call an adapter, and it adapter is basically an adapter between the vector database and the embed anything. So as soon as the embeddings are being generated, they are slowly moved into the vector database itself. So there are a few things that need to be done to kind of achieve this. So because we do not want to have a lot of dependencies within embed anything, so what we are given is a skeleton of an adapter which needs to be filled based on which vector database service you're using. So for example, here we are shown an example for like a Elasticsearch adapter. So you basically need to create a few functions like creating the index, so which is shown here. I'll also show you a demo in a while. And then you need something to convert from the embed anything's metadata schema to into whatever the end vector database expects as a schema. So that conversion, a function for that needs to be written by you, but we have already written for most of the databases and published it on our repository, so you can just quickly copy paste from there if you need. And also a function to upsert those embeddings into the database. So at the end you just integrate all this. So I quickly show a demo of this working. Yeah. So this is a notebook which is also on our repository, which you can quickly check out and use as a starter. starter for your application. So we have two versions of embed anything. So one is a GPU version and a non GPU version. So we'll be using the GPU version over here. Um, uh, Obviously GPU is not given. Okay. Oops, sorry. Think I'm in the wrong one. Oh yeah. Yeah. Yeah, so we just clone the repo. So these are just boilerplate things which we do. So over here you see the adapter that is mentioned. So this adapter basically is for Elastic. So just defines a few handy functions to use with the with embed anything. So we'll quickly just get everything that we need. Here we create the index. We'll call it anything, and also we then create the index and define how much dimension it is going to be. And the magic call happens with this piece of code. So you're basically embedding the whole directory that is over here, which is in test files, and just calling the adapter over there. So this connects the whole the vector database, and as the embeddings are being generated page by page, they are actually moving into the database. So you will not see almost only the memory that is being used here essentially would be your model. So apart from the model, there will be hardly any memory usage happening. So this as this runs, so we can do a simple query. We can say what is an SSM model, and use the search functionality from Elasticsearch. And yeah, so gives you good handy metadata. So what is the file name as well, when was it created, and those things, and you get the output. And the fun part is this, because we support audio as well, so we can integrate audio decoding and then streaming as well into the same with the same index. So this is a audio clip of someone talking about screwdrivers. So we can move that to the same index, and now we have audio being converted into embeddings with text. So we can even search across that and get things about crosshead screw design and search for those things. Yeah, and please give us a like on our GitHub repository as well. Just the last thing what we wanted to show is what we are working on next. So we are looking working on using more inputs like graph embedding. So video embedding is something which we are actively looking at, and also increasing the number of expanded file types. So we have PDF, but we want to even support docx and Excel files, and also have a wasm support in embed anything itself as well. So right now you can do it, but you have to do it yourself, but we wanted to make that easier for you as well. And also we want to integrate with more vector databases, provide those adapter code for other databases as well. And as Sonam mentioned, we want to integrate some fine tuning aspect, like sentence transformer release their fine tuning version. So this can be done in Candle, and it works more efficiently. So we want to release that as well. So yeah, that's it from us. If we have any questions, feel free to put them in chat. Yeah.
Hi, yes, I saw that we had a couple questions that were being answered. I know you had responded to this, but maybe just for the audience who maybe didn't see it, did you want to address this real quick?
Yeah. So we are not so much into LLMs and SLMs right now. The only large model that we support is the ColPali, which is again
Yeah.
essentially an embedding a model. So as of now, at least in embed anything, we wanted to be focused on just embedding models. So we are not using any LLM or SLM. It's basically models like Gina embedding models and BERT models, which are all mini LM. or BGE models. So those are the models we support. You can look at our page. So we have listed
Uh,
all the models
I
we
would like
support.
to add one thing that Candle is actually made to support all kind of transformer models, so it can support LLM, and maybe one day we will consider it adding it to embedded anything as well. But right now we only support embedding models, and we are kind of like an accessory to vector database, rather than like making agents. Yes.
Awesome. Thank you. We had another question. Can I use my own fine-tuned embedded model?
Yeah, you can use it. You can just put it on Hugging Face, and if it is one of the architectures that is supported by us, you can just put that as a model ID, and you will be using your fine-tuned model. So it's as easy as just changing the model ID.
I saw that you had posted the repo. Is there also a link to the slides that we can share?
Yeah,
Uh,
yeah.
yeah, I
You can share the
will.
site as well.
Yeah, do that.
While she's doing that, are there any other final questions in the last minute or two that we have that someone might have?
And I just want to add that do try embed anything and then raise any kind of issue, raise features, bugs, and like please give us a star because it's very kind of important for us. Thank you.
Great. Yeah, is there a link that we could share, or should we do it afterwards?
You were sharing a
Did you share the? Oh,
yeah,
I should I share? Okay, yeah. I'll just
yeah,
put it here.
yeah.
Yeah.
Awesome. Yep, it looks like it's in the Q&A chat there for anyone to grab. Yes, thank you for doing that. That is great. I think we are wrapping up at time, so it's a good chance to wrap up. So thank you so much for presenting today. We really appreciate it, and thanks to everyone for attending the talk. This recording will be available as a playback on the AirMeet platform, including after the conference itself wraps up. So even after today, if you are interested in going back and rewatching some of these parts, you can still log on to the platform and watch any of the videos from the last 3 days. So with that, thank you so much, and have a
Yeah.
great day.
Yeah. Thank you. Thank you very much. See you.